In this question, the mass is 0.2 and we have a velocity 8I minus 15J, and it hits a smooth barrier along the I-axis, so no change in I, just the J change. And the coefficient of restitution is 2/5. So the new, which we'll call x, over the old, which is minus 15 in the J, is equal to minus E, so 5x is equal to 30. So x is equal to 6. So my new velocity is 8I plus 6J. The magnitude of this one is going to be square root of 8 squared plus 15 squared. And the magnitude of this one is the square root of 8 squared plus 6 squared, which you guys know is 10. This is the square root of 289, which is 17. And we're asked the new velocity of the ball, which we have here. It's part 1. The speed of the ball falls by 7. Well, 17 minus 10 is equal to 7 for part 2. And part 3, the loss in kinetic energy. Well, what's this change in half mu squared? So we start off with a half. But I'll put it as a fraction actually instead of 0.2. A half times 1/5 times 17 squared is what it started with. Then it ended up as a half times a fifth times 10 squared. So this is 289 divided by 10, 28.9, and 100 divided by 10 is 10. 28.9 minus 10, 18.9. And that's measured in joules, spelled incorrectly. Joules are just capital J. Will do. This is in meters per second. Just put your units in. I'm being a bit lazy. And that's question 7. In this question, mass is 4. Hits along the I-axis again, so just J change here. And we're told the velocity before and the velocity after. So before, after. So minus, we have the plus 4 on top. After over before is equal to coefficient minus the coefficient of restitution minus E. So that would give, if you want to cross multiply, you could say 6E is equal to 4. So E is equal to 4/6, which you could see originally, which is 2/3 for my coefficient of restitution. Percentage loss in kinetic energy. Okay, let's look at before, the speed, and after. So the magnitude before is the square root of 8 squared plus 6 squared, which is 10 meters a second. And afterwards, we have 8 and 4, the square root of 8 squared plus 4 squared. 64 and 16 is root 80, which we could simplify, but we don't need to. We leave this root 80 for now. Loss in kinetic energy, so a half mu squared applied to both is going to give a half. Mass is 4 times the velocity squared times 10 squared. So we have 2 times 100, which is 200. And afterwards, we're going to have a half times 4 times the square root of 80 to be squared, which is twice 80, which is 160. So we put our joules in. We've gone from 200 to 160. So we've lost 40 out of a total of 200 that we started with. So 4/20 is going to be 1/5, which is 20% loss in kinetic energy. And then we're told the ratio, tan B or tan A, where A and B are the acute angles with the line of motion, make with the I-axis before and after impact respectively. So these angles, tan A, well this is A is before and B is afterwards, and the tan of the angle, so tan A is going to be the 6/8, J/I, that's A, and tan B, 4/8. So we're asked for tan B over tan A. Well, that's, we can simplify them. That's 1/2, and that's 3/4. So we have 1/2 divided by 3/4, which is equal to 1/2 times 4/3, which is equal to 4/6, which is equal to 2/3. So in this question, the mass is 0.2, and it hits along the J-axis. So it's I change here. Just be careful to read the question properly. So we're told before impact, 4I plus 3J. And the coefficient of restitution, 0.75, 3/4. Find the velocity after impact. So we're looking at change in I here. So afterwards, x over before is equal to minus e, minus 3 over 4. So 4x is equal to minus 12. So you can see x is going to be equal to minus 3. It has to be the same as the other side. So after, we're looking at minus 3i plus 3j. We're going to need the speeds here because we're looking at percentage loss in kinetic energy. So the magnitude of 4i plus 3j is equal to 5 meters per second. You know that already. And this one down here, the magnitude of minus 3i plus 3j is the square root of 9 plus 9, square root of 18. And we're looking for the percentage loss in kinetic energy. So a half mu squared for this one, a half mu squared is equal to a half 0.2 is a fifth by u squared, which is 5 squared. So 25 over 10 is 2.5. And down here, a half mu squared will be a half by a fifth by the square root of 18 to be squared, which is just going to be 18 over 10, which is 1.8. So the loss is going to be 2.5 minus 1.8. That's a decimal in there, which is equal to 0.7. And the 0.7 was out of 2.5. And if you multiply that by 100, it's going to be just 28%. 7 over 2.5 is going to be 28%. Multiply both of them by 4. You'll see the 28% here. That's question 9.